Good morning everyone and welcome back to 2214 class. And in this video we're going to discuss the second part of the hash and hash map. And specifically in this video we're going to discuss the hash map, and you can see in this notepad what we show. So when I read through the component of both the hash and the hash map, I'm trying to see what exactly is the difference between these two parts, and what is the motivation that we have a hash map. And I would like to share some of my feeling about this part with you. Okay, so if you look at the hash, as we discussed in the previous video, the hash is basically, for whatever reason, my writing pad does not like the character S today. I cannot write S, okay? So when we talk about the hash, we are actually saying, hey, we're going to group data into bucket. And in every bucket, we can have multiple data points, okay? So basically, it's very possible that we have collisions. It's very possible that we have collisions. So you may have multiple entries falling into the same bucket, and so on and so forth. And then, of course, you need to store. So if you recall, so let's say these are the hash. So each one of it's a bucket, and here we draw a linked list. Okay, so let's say record 1, record 2, record 3, so on and so forth. Okay, so you can see the hash function only provides the surface to group, and then you have all the objects stored here. It's either in the linked list or in the linear probing or whatever data structure you're using to actually store the record. So let's say if you want to do some search, let's say if you want to do add, oh God. So let's say if you have a hash, if you want to do add, search, remove, so what will be the procedure? You first use the key and to map it to a bucket. And once you go to the bucket, you search in the bucket. Okay? And in this way, if there is something already in it, and you can either search it or remove it. If it's not there, if you want to add it, you can add it. So you still need to go through all the procedure. There are some applications that we want a faster operation. So in this way, HashMap provide a very good example. Okay, from my understanding, you may have a different understanding. I will totally understand. A hash map is a very good two-dimensional, so we call it a two-dimensional data structure. Okay. It's a very good, it's a very interesting two-dimensional data structure. So on one side you have the key, and on the other side you have the value. For example, your student ID. And on the other side, we have your GPA. So in this way, it is actually, when we say a two-dimensional word, is actually, you can see a record. Each entry in a hash map is a record. And here I have the record in a parenthesis. This is the key. And this, you can see, is the feature. I will try to write it slow, and oh God. Oh. So this is the key, this is the feature value. For example, your student ID is the key, your GPA is your feature value. And or it is your SSN is the key, and the date of birth will be the value, so on and so forth. So you can see this will be something unique, and this will be a property associated with the entity. And of course, if this can be some primitive value, such as a GPA, it's a float, or it's a date of birth, it could be more complicated data structure or more complicated object of a class. Okay, that's all possible. But in this way, if your input is the key, we can directly get access to the value you want to access. Instead of if you are talking about a hash table. So this is what happened. Okay, you first get the key, and then you find all the bucket, you find all the entries in the bucket, and you try to search in it. Okay, so from this point of view, I think HashMap provides a much more efficient way to access specific features associated with an entity. Okay, but you can imagine this two-dimensional structure has a drawback, which it does not like collision. In other words, you cannot have two entries with the same key. Okay, you cannot have two entries with the same key. So if you said, hey, student ID, if the GPA is 3.9, it is 3.9. You cannot add another entry said, oh, I have another student have the same student ID, but her GPA is actually 4.0 instead of 3.9. The HashMap will not support that. It is a one-to-one mapping. That's why you can see in the example provided in the Zybook and realize it, these are all the things that we try to enforce. Okay, so let us see an example. So this is an example in the Zybook. Okay, so you can see the code. There is a hash map, and the key is an integer, and the features or the value is actually a double number, and you need to new a hash map with the integer and the double. And if you want to add something into the hash map, you need the value of put. And if you want to search in it, you want to call the function called get. Let me see. Yep. These are the frequently used functions of a Google HashMap. We just see put, and remember the put will have the capability to override. If the key already exists, you're going to replace the new value. Okay, and you can also have the put if absent. Only if there's no such things in it, you're going to add it into the. So whether or not there is already a record contain the specific key, and remove, clear, and so on and so forth. Okay, so these are the features, or these are the method associated with a hash map. Okay, and when we talk about, or when you do the lab of this week, there are several things I want you to be extremely pay special attention to. Okay, so first thing, when you implement something related to a hash map, what is the structure of the hash map? In other words, what is the key and what is the value? Is that a string? Is that a float? Is that a double? Is that an integer? You need to think carefully. So the key is used to locate an entry, and the value is really something you want to store. Okay. The second feature when you deal with the hash map is what to add and what not to add. Okay, so basically when you read through the instruction, not only the lab but also in the future in your job related case, so we will have a new entry we want you to add into the hash map. We call it put. Okay, is that you always put, or only when there is no such things, there's no record about this key already in the system, you will put. So in this way, are you always calling the put, or are you only put if there's no such entry? Or is there some other conditions associated with the adding operation? And the third thing I want you to pay special attention, because this is directly related to our lab, is what to return. What to return? Are you operating on the current hash map directly, or do you need to create a brand new hash map? Okay. So now we're going to see the labs, and we're going to explain one lab in detail, and then the remaining, of course, you need to do all by yourself. So in this interface, you can see we're at NetBeans, and this is actually the map, the zip file we provide. Okay, let's load it. So as the instruction mentions, you don't need to add extra library into it. Okay, so this, you can see the file, the student record is used in one specific case, in one specific function you need to implement. But let's look at this one. Okay. So this is a little bit different from the Zybook thing. If you look at the Zybook Xaml code, they directly use HashMap, and they don't really use the generic class of the map. And in our code, we use both. Okay, so these are the map problems, and this is actually the first function you need to implement. Okay, it says modify and return the given map as follows. Okay, so now when we read this sentence, let's answer some of the questions associated with the topic we just discussed. What to return? Are we going to return a brand new hash map, or are we going to update the current hash map? Based on the description, it seems that we're going to operate on the current map directly. Okay. If the key, okay, there's a key A has a value. In other words, if this guy already exists in the hash map, set the key B to have that value. So basically, you're going to get the value associated with key A and give it to the key B. And set the key A to a new value of empty string. Basically, B is confiscating the value and replacing. Okay, so let's say we need to remove this thing, and we already have the map here. Okay, and we need to see, okay, the question is if the key has a value. In other words, if obviously, okay, you need to consider the scenario. So here we said, it says modify and return if the key A has a value. In other words, if this map already contains the corresponding key here we're talking about, then set the key B to have that value. Okay, so when you need to set somebody's value to it, the easiest way, as the Zybook mentioned, is just to call the function of put. So in this way, it will, no matter whether or not it exists, it will override the existing value. The only thing here we want to be very careful is it says if the key A has a value, so the value is actually associated with the key. You're not adding A into the as B's value, but as the value associated with the key A to become the value associated with KB. Okay, the key B. So in this way, when you add something into the map, you actually need both the get function and the put function, and then you will set the key to the value of an empty string. Okay, so in this way, I have like one kind of hint for the first exercise, and do not forget, okay, do not forget this function or this method expect a map returned. So since you are actually operating on the input map, you need to return it after you finish updating. Okay, this is one thing I want you to be very careful. The second thing I want you to be very careful is, what do you need to do if you need to new a map? Okay, So let's see. So if we look at this example, the input is just an array list of strings, and the return value will be a map. So obviously you need to new a map. You need to new a map. And the map needs to have the structure of a string and integer, okay? However, if you look at the map itself is an, I believe is a generic object, or it's more of a kind of ADT. You don't really initiate a map, but you actually initiate a hash map. So be very careful in this type of exercise when you define the variable what it is, and when you knew that what it is, okay? Is the variable, the class is an object of map, and when you knew it, are you knewing a hash map, okay? This will be a very, something you need to pay attention to. For example, if we have here, we will define a variable of the type map that they want. Let's call it a result. All right, map. Can we do that? So obviously there is some warning, kind of. It says map is abstract, cannot be instantiated. Okay, so you cannot really new a map. You have to new a certain type of things that the system can actually recognize. Okay. With this, I hope that I provided enough information for your Lab 9, and you can kick off with the hash mapping exercise. Okay. I will see you in the next video. Thank you.